Hello everyone, very good morning and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Yes, please. In this session, we are going to discuss non-inverting operational amplifier and voltage follower. Okay, and I will give you the application of voltage follower, like first order butterworth filter, sample and hold circuit. Okay. First of all, inform me that sound quality, picture quality, everything is fine. Then this topic is important for GATE exam, engineering services exam, and this is important for what? Electronics, electrical and instrumentation branch. Okay. Chaudhary, very good morning. Sanjay Sir, very good morning. Battery Soria, very good morning. चलिए start करेंगे. If you have any doubts related to that operational amplifier, then you can ask. Right. That is my introduction. Myself Sanjay Rathi, 21 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU. Your voice is low. Okay, 1 minute. Give me 1 minute. I will check. Hello. Now everything is fine. Okay then. That is my experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008. Okay, then this is golden opportunity for you. 90% scholarship test, that is the 90% scholarship on GATE preparation programs. Please note the date, that is what, 12th June at 11 AM, right? Register now. If you want to give this test, then it is for you, and that is my schedule. Already that session is over. How to get the command over analog, please watch this so that you will get the idea. What about the syllabus? What about the important topics? What about the weightage of the important topics? Second thing, how to make short notes, detailed notes, each and everything I have discussed in this session. Then second, basic of operational amplifier means internal structure of operational amplifier, equivalent circuit of operational amplifier. Then inverting operational amplifier with important numericals. Now we are going to discuss non-inverting operational amplifier and voltage follower. Daily classes at 8 AM. So like the session, share the link of this session and subscribe our channel. Okay. Then already I have given the characteristics of the operational amplifier. It is initially designed to do the mathematical operation, and that's why it is called operational amplifier. It is a voltage controlled voltage source, right? Input resistance is very high, output resistance is very low, voltage gain ideally infinite, gain bandwidth product should be infinite, it should be very, very high. It is a multi-stage amplifier, it is a direct coupled amplifier. Give me the answer, which is the most popularly used operational amplifier, everyone, dreamer. So that is the most popularly used operational amplifier, already we have discussed. That is the internal diagram, already I have discussed. This is the R in, this is the R out, this is the voltage controlled voltage source, right? Inverting terminal, non-inverting terminal. Now we are going to discuss non-inverting operational amplifier. Ideal condition, practical condition and related questions. That is, watch this diagram. What about the feedback? This feedback, when the output is connected to the inverting terminal, that is called negative feedback, and the input is connected to positive terminal, and that's why the phase shift of this circuit is 0 degree, because it is connected to positive terminal, and that is called what? Non-inverting operational amplifier. Yes, Sai Charan, your answer is correct. IC 741, so correct. So that is the IC. Varakala, your answer is also correct. That is the IC 741. So that is most popularly used operational amplifier. Now Always remember, when we are designing any type of amplifier or control circuit, voltage regulator, then we are using negative feedback, right, to stabilize the system. So here again the feedback is negative, but input is connected to positive terminal, and we will solve one question here where both the feedbacks are present, negative feedback as well as positive feedback, both present. Then how to check which feedback is dominant, negative feedback or positive feedback? Because when the negative feedback is dominant, then we can apply what virtual short concept, right? So for example, this is the diagram for operational amplifier. Watch this carefully. Normally this is the negative feedback, this is RF, this is R1, this is connected to ground, and here this is the plus, this is the 1. Here we are giving the input Vs, and that is called negative feedback. If the negative feedback is dominant, then virtual short concept is applicable. So Vp is equal to Vn, Vp is equal to Vn is equal to what? Vs. This time this is the Vs. When I writing the KCL at this point, Vs minus 0 by R1, Vs minus V0 by RF, then Vs minus 0 by R1 plus Vs minus V0 by RF. Arrange this KCL, that is the KCL at an inverting terminal, that is the Vn, and Vn is equal to Vs. Then you will get V0 is equal to 1 plus RF by R1 into Vs. And what will be the gain? V0 by Vs is equal to 1 plus RF by R1. That is the simple gain with 0 degree phase shift. If you have any specific doubt, then you can ask. Yes, please go ahead. Related to what? Non-inverting terminal. Okay. That is the first case. 1 plus RF by R1. Now try to solve this question. Everyone give me the answer for this question. 1 plus RF by R1 is the gain. Phase shift is 0 degree. Right. Remember, in case of non-inverting operational amplifier, the feedback mechanism is voltage series feedback. Voltage series feedback. Okay, everyone, if suppose you are attending the regular classes, what is the feedback mechanism in case of inverting operational amplifier? In previous class already I have given you the answer. Feedback mechanism in inverting operational amplifier. Everyone give me the comments in comments box. Inverting operational amplifier. Then that is first question. Second thing, let's try to solve this question. This is RL, this is 10 kilo ohm, let this is 1 kilo ohm, this is ground, and this is Vs. Let this is 1 volt. RL is equal to 10 kilo ohm. This is V0. Everyone, what will be the value of I? What will be the value of I in this question? Assume ideal operational amplifier. Assume ideal operational amplifier. What about the feedback? Voltage shunt feedback. बिल्कुल सही, जितने लोगों ने भी दिया है, सपना, ड्रीमर, चंद्रशेखर, आराम. तो what is the voltage shunt feedback? Gautam Das, that is your answer is correct. Surya, your answer is also correct. Voltage shunt feedback in case of inverting op-amp, voltage series feedback in case of non-inverting operational amplifier. Because they will ask MSQ question. In MSQ theoretical question, the one line feedback mechanism is voltage series or voltage shunt. Then second one, what is the current in this diagram? what will be the current? If you want to calculate, everyone use your rough copy and try to solve this question. I am going to solve and give your answer in comments box. This is 1 volt, 10 kilo ohm, 1 kilo ohm, RL is equal to 10 kilo ohm. It is given. So what is the method here? Always remember, if this is the current, this is the I, there will be the IL and there will be the current I1. Now this same current will pass here. Why? Because the current enter into the operational amplifier is 0. Here it is 0, here it is 0. The same current will pass through this I1. Then what is the incoming current at this node I? What is the outgoing current? I1 plus IL. Then how to find the IL? V0 upon RL. And how to find the I1? Try to understand. The same I1 pass through this. So what is the voltage at this point? Vn. Vn is equal to Vp. So Vp is equal to Vn is equal to Vs is equal to 1 volt. The current passed from passing through this point to that point, and that's why we can give Vn minus 0 by R, that is 1 kilo ohm. So I1 is nothing but Vs by 1 kilo ohm. Or I can say R1. This is the RF, this is the R1 plus V0 by RL. Okay, so what is the answer here? 2.1 milliampere. Okay, I will check. Everyone give me the answer. What is the current here? So this is the I1, that is the IL, and that will be the. How to find the V0? Because it is a non-inverting operational amplifier, V0 is equal to 1 plus RF by R1 into Vs. 1 plus 10 by 1. 1 plus 10 by 1, that is into Vs, 1 volt. That is nothing but it is visible to you, 11 volt. 11 volt is the output voltage, right? What is the value of the current now? Vs by R1. What is the Vs1? What is the R1? 1. 1 divided by 1, that is equal to what? 1 milliampere. Plus, sorry, this is the, yes, 11 volt divided by RL. 11 volt divided by RL. What is the RL? 10 kilo ohm. So this will become 1.1 plus 1, that is what is the answer? 2.1. 2.1 milliampere will be the current. So that is given by Sivu, Manvendra, Sapna. Yes, that is the right answer. 2.1 milliampere. Okay. Now, if simply I am changing the value of RL, I am changing the value of RL. Let it is a variable. If I am giving you the second question, let it is 1 kilo ohm. It is reduced by what? 10 times. 10 times. This is the 10 divided by, that is the 10, that is it will become 1 kilo ohm. What is the change here? This Vs will remain same, this R1 will remain same, this current will remain same, RF will remain same, R1 same, V0 will remain same because it is independent of RL. Everything will remain same, but only this will change. So what is the new value of the current? So what is the new value of the current? 1 minute. Now, simply, if RL is reduced, I is given by 1 divided by 1 plus 11 divided by 1, that will become 12 milliampere. 12 milliampere increases, current increases 12 milliampere. Initially it was 2.1 milliampere, now it is a 12 milliampere. In both the cases, try to understand the concept. In both the cases, what is the current given by the Vs? Everyone, what is the current given by the Vs? In first case, when the RL is 10 kilo ohm, what was the current? Same. 0 current is given by the Vs. In second case, when RL is 1 kilo ohm, Again, what is the current given by this Vs? 1 volt, 0. So what is the input resistance seen by the Vs? Ideally it is infinite. Why? Because what is the current given by this Vs? 0. Means we are changing the value of load. We are changing the value of load, but what is the current given by the Vs? It will remain 0. No loading effect. That is called no loading effect. Second thing, V0. V0 is independent of what? RL. Independent of RL. V0 will remain same, and it depends upon what? Vs. We are changing the value of Vs, output will change. Otherwise, it is independent of RL. Is it clear? So this is a voltage control voltage source. Output voltage is controlled by the input voltage. And when I am changing the RL, there will be no change in V0. Right. So that is the concept. Now, that current, actually the duty of, what is the duty of the operational amplifier? Finally try to understand this concept. Then I will give you the idea about the voltage follower. What is the use of the voltage follower? Now, always remember that is the internal diagram of the operational amplifier. When there is a 0 degree phase shift, this is the plus, this is the minus, this is the R0, this is RF, this is R1. Here we are connecting the Vs. This is the input resistance Ri, and this is connected to ground. Now, here we are connecting RL. In this branch, the current will always remain same, but this current will change. What is the path of this current? That is the path. When we are decreasing the value of RL, when the RL decreases, IL increases, therefore I increases. From the two examples, it is clear that when RL decreases, means what is the loading increases. Always remember, when RL, load resistance decreases, loading increases. Increases means more load current is required, and therefore I increases. If that will be the case, IL increases, that is called loading increases, I increases. Extra current will be given by the operational amplifier. Extra current is the duty of this operational amplifier. Simple. I think that concept is clear. So, this type of circuit we are using, right? Output will not change, the quality of the output will not change with variation in RL, right? Now, here we are getting the gain 1 plus RF by R1 into what? Vs. Suppose we want same input, the input should remain same, then what should be the gain of the system? 1. What should be the gain of the system? 1. Then that circuit is called what? Voltage follower. Voltage follower means in the same circuit, if RF by R1 is very less than 1, then what will be the gain? What will be the gain? 1 plus RF by R1. RF by R1 is negligible. The gain is equal to what? 1. Gain is equal to 1. Gain equal to 1 means output voltage will follow the input voltage. Output voltage will follow the input voltage, and that's why it is called voltage follower. Voltage follower. A number of students will ask, sir, what is the use of the voltage follower? What is the use of the voltage follower when the gain is 1? Right? So, because when the gain is 1 means it will not amplify the signal. It will not amplify the signal. So, normally we are giving this type of diagram. This is called voltage follower. Here this is the Vp, here this is the Vn, here this is the V0. because there is a negative feedback. V naught is exactly equal to Vn. Vn is equal to what? Vp, and Vp is nothing but Vs. From this, V naught by Vs, that is called closed loop gain, is equal to 1. Now, remember 1, the gain of this system is what? 1. But if suppose we are giving the Vs, when I am connecting RL here, variable RL. Try to understand this diagram. That is the modified version of this. I am making the Rf is equal to 0, R1 is equal to infinite, R1 will act as open circuit, Rf will act as 0, and that's why this point is connected here. Here R1, there is no R1, means R1 is equal to infinity, Rf is equal to 0. Finished? Now this is called voltage follower. What is the current in this branch? 0. For example, if Vs is 1 volt, output will be 1 volt. This is the current IL. Now what will be the IL? IL is equal to V naught by RL, that is nothing but Vs by RL. Okay. No doubt, output voltage is equal to what? Input voltage. But continuously I am changing the value of RL. What about the requirement of the current? It will increase. If I am decreasing the RL, IL will increase. If I am decreasing the RL, IL will increase. Right? That is called more current is required. But every time the current given by this battery is 0. All extra current will be given by this. And that's why it is called buffer. Current gain should be high. It will provide the required current. I think that concept is clear to you. This is clear to you. It will provide the required current. That is the use of the voltage follower. This is the voltage follower. But always remember, energy can neither be created nor be destroyed. We are giving the supply here. This is called Vset. And that is called minus Vset. Plus 15. Normally in case of IC 741, we are giving the plus 15 and minus 15 volt. Okay, that is the supply. Now, any other application of the voltage follower, please give me in comments box. Any other application of voltage follower. Then just I will give you some practical formula for non-inverting operational amplifier, because in GATE exam they will ask question from practical operational amplifier. That is, what is the use of that? Then this is about the internal structure of the inverting. When there is a variable load, what will happen? Then that is the voltage follower. Now, practically, always remember this diagram. What will be the question? Each and everything about non-inverting operational amplifier. First thing, please make your own notes just with me. First point, feedback mechanism is voltage series feedback. Voltage series feedback. Second point, it is a practical operational amplifier. Practical operational amplifier. For practical operational amplifier, always remember AV is not infinite. Any value is given like 100 or 50 or anything else. Ri is not infinite. Anything will be given like 1 kilo ohm or 10 kilo ohm, everything 10 kilo ohm. R0 is not a 0. R0 is given as 10 ohm, right, like this. If that will be the question, always remember here the feedback mechanism is voltage series feedback. Find the exact gain, that is given by V0 by Vs AV upon 1 plus beta AV. AV upon 1 plus beta AV. This 1 plus beta AV is called what? Desensitivity. 1 plus beta AV is called desensitivity. Desensitivity. 1 plus. What is the beta here? R1 upon R1 plus RF. R1 upon R1 plus RF. That will be the value of beta. Now, what will be the practical question? First, what is the exact gain? AV upon 1 plus beta AV. What is the beta? R1 upon R1 plus RF. What is the feedback mechanism? Voltage series feedback. Third question, what is the input resistance seen by this Vs? What is the input resistance seen by this Vs? Now you will say that, sir, it is infinite. No, practically it is not infinite. Practically it is not infinite. So what is the Rin? Ri 1 plus beta AV. Input resistance increases by desensitivity factor. So that is the Ri for open loop operational amplifier. These are the characteristics of open loop practical operational amplifier. What is the resistance seen by Vs is given by input resistance of the op-amp into 1 plus beta AV. What will be the R0? Right? R0 means what is the output resistance, or we can say RTH, Thevenin's resistance at this point. Always remember, with feedback हम इसको R dash बोल सकते हैं और RTH बोल सकते हैं, RTH. That will be R0 upon 1 plus beta AV. Always remember, in voltage series feedback, output resistance will decrease. So that will be divided by 1 plus beta AV. That will be multiplied with the 1 plus beta AV. Okay, and that is the answer for this particular question. What will be the last question? Suppose for open loop system, bandwidth is given. For example, it is a practical operational amplifier. Here the bandwidth is mentioned here. Like this is the bandwidth. Anything, if the bandwidth for open loop system is mentioned, always remember, if the gain reduced by 1 plus beta AV, this is the open loop gain, that is the closed loop gain. If the gain reduced by 1 plus beta AV, then the bandwidth will increase by 1 plus beta AV. So what is the bandwidth for closed loop system? That is given by bandwidth for open loop system into 1 plus beta AV. Why? Because the gain bandwidth product is constant. Gain bandwidth product is constant. So when we are getting the practical operational amplifier, always remember you have to follow all these formula: voltage series feedback, AVS, 1 plus beta AV, R1 upon R1 plus RF, Rin, R0, right? And then bandwidth they will ask. चलिए मैं एक क्वेश्चन पूछता हूँ. Tell me what is the value of the beta for voltage follower? Voltage follower is nothing but a special case of non-inverting operational amplifier where RF is very small as compared to R1, or RF by R1 is very less than 1. Tell me what is the beta for voltage follower? What is the value of the beta for voltage follower? That is written here. R1 upon R1 plus RF. This is for all the values for non-inverting op-amp. Non-inverting. Here we are discussing the non-inverting op-amp and voltage follower. Right. Now, voltage follower is a special case of what? Non-inverting op-amp. Yeah, please like the session, share the link of this session so that the student will join. Yes, please ask them to join, because now tomorrow I am going to discuss what? We will discuss differential amplifier, and then we will discuss what? That voltage to current converter. That is important topic. And now I am going to discuss a question that have both the feedback, positive feedback as well as negative feedback. Right answer, that is nearly equal to 1. Yes, beta. If here, because that I can write 1 upon 1 plus RF by R1. Always new student try to understand. We can write it like that. Divide numerator and denominator by R1 and Rf by R1 is very less than 1, and that's why we can neglect that term, and this will nearly equal to what? 1. It is nearly equal to 1. That is the Cebu. You have given the practical answer just like what interview. Sir, it is nearly equal to what? 1. We can't say that exactly equal to 1 practically. Yes, that is right answer. Now, for voltage follower, remember that beta is nearly equal to 1. Finished. When beta is 1, everything is over. You can use that formula. Input resistance 1 plus beta AV. Output resistance R0 upon 1 plus beta AV. In the place of beta, use 1. Right? What will be the gain? AV upon 1 plus beta AV. It is just slightly less than 1. They may ask question. They may ask this type of question. What is the closed loop gain for voltage follower? Everyone tell me, exactly 1 or less than 1? Exactly 1 or less than 1? That will be the question. Sir, why we not calculate bandwidth in case of inverting? We can calculate, no problem. We can calculate the bandwidth, but Sapna, always remember that in case of inverting operational amplifier, what is the feedback? Voltage shunt feedback. So when the voltage shunt feedback, no doubt we are writing the beta, but in case of feedback, when I will give the session on that feedback topology, how to calculate beta, that approach is entirely different in case of voltage shunt feedback. That is the case, right? Yes, Sibu. Chale. So that is, yes. So yeah, this type of question in MSQ, we are saying that exactly 1. Exactly 1, it is not possible practically. Nearly equal to 1. Or if suppose I am watching this formula AV upon 1 plus beta AV, nearly beta is 1. This numerator term, denominator term is greater than that. So definitely it will be less than 1. It will be less than 1. So if there will be a 3 option, just slightly less than 1, exactly equal to 1 or greater than 1, then it will become very difficult for us, right? So please use this type of formula. What about the input resistance? Same, because it is a, you have to use the beta is equal to 1, beta is equal to 1 here, beta is equal to 1 here, desensitivity, that is the value, and so on. Now, just try to solve this question. Easy. Then I will give the application of the voltage follower. 1 minute. Yes. First of all, what is the, yes, in this diagram both type of feedbacks are present. Normally all the questions that is based on what simple diagram, but here there is 2 feedback, yes or no, that is visible to you. R1, R2, that negative feedback is present, R1 and R2, as well as there is a positive feedback is also present. Negative feedback present, positive feedback present. If suppose we are going to use the virtual short concept or virtual ground, then there should be negative feedback. Tell me in this diagram which feedback is dominant, everyone. In this diagram which feedback is dominant? Then it will become very difficult for us how to find which feedback is dominant, because ultimately we have to find the V in by I in, but we are using the virtual short concept, or whether the virtual short concept is valid or not valid, it depends which feedback is dominant. Now tell me how to check. Just watch this diagram. If there are, always remember, if both the feedbacks are present, then how to check? For example, in this diagram, this is V in is connected here. Here the V in is connected. This is the voltage V in. One feedback is connected, impedance is connected here, no problem. This is called positive feedback. This is the negative feedback. Right, R2 and R1. Okay, this is the V0. This is any value Z. Right. First find what Vp and Vn. Always remember, if that is the question, both the feedbacks are present. So what is the method? Virtual short concept, no need to use. First of all, find the Vp in terms of as a function of what V0. Find the Vn as a function of what V0. And make all Vs or Vin 0. Or if there is a current source or I in, that is equal to 0. If there is a current source, make it 0. If there is a voltage source, make it 0. To make the voltage source 0, input voltage source, make it what? Short circuit. To make the current source 0, make it what? Open circuit. For example, in this diagram there is a voltage source. Then make it short circuit. When I am making it short circuit, what is the value of the Vp? Everyone tell me. If I am making it short circuit, then the Vp will become 0. Vp will become 0. Now what is the value of the Vn in terms of V0? So when I am making the Vin is equal to 0, Vp is equal to 0. Vn is equal to R2 upon R1 plus R2 into V0. Simple voltage division rule. Why? Because what is the current enter here? 0. What is the current enter here? 0. And that's why it is visible. It is visible that Vn is greater than V0. If the Vn is greater than Vp, Vn is greater than Vp, now tell me which feedback is dominant. Now we can say the negative feedback is dominant. If the negative feedback is dominant, then virtual short concept is valid. Virtual short concept is valid. Now this question becomes very, very easy. Now you can solve this question. I will give you where the positive feedback is dominant. Try to understand. First of all, watch this diagram. Once the negative feedback is dominant, that is the given, negative feedback is dominant. Simple virtual short concept. This is the Vp, this is the Vin. Vp is equal to Vn is equal to Vn. What is asked here? What is the V in by I in? We have to find the V in by I in. So that is the incoming current. That current will pass through the Z. Same current will pass here. What is the voltage at this point? We can write the current I in is equal to V in minus V0 by Z. V in, voltage at this point is V in minus V0 by what? Z. What is the V0? You can find the value, or simply you can find the value of V0 in terms of V in, because the voltage at this point and voltage at this point are same. V in is equal to R2 upon R1 plus R2 into V0. So what is the V0? 1 plus, right? This is the R1, R2, that is the R1 by R2. 1 plus R1 by R2 into what? V. Put here and you will get the answer. Yes, I think that is clear to you. This V in cancel and you will get the minus R1 by R2 into V in. So what is the V in by I in? That will be the answer in negative. So what is the V in by I in? Minus Z R2 by R1. Check my calculation. Minus Z R2 by R1. So minus Z R2 by R1 or R1 by R2. Please check my answer calculation, है ना? So that is the method. That is the simple method. R2 by R1 plus R2. Yes, up to this point everything is fine. Then that is yes. When I am writing V in cancel and you will get the answer from this particular question. Okay. Sapna, always we check which feedback is dominant by Vn is equal to Vn is equal. If both the, suppose if positive and negative both feedbacks are present, then you have to check. Then you have to check. Yes, we have to check. Right now, once the negative feedback, then virtual short concept. This is the V in, that is also V in. Check my calculation in simple. I in, how I can write the V in minus V naught upon Z. So I am writing the V in minus V naught upon Z. Then find the V in, that write down the KCL, or simply you can find the what is the voltage at this point, R2 upon R1 plus R2 V naught, that is nothing but V in. Compare it and you will get the value of what this V naught in terms of V in. Put here and you will be able to solve this particular question, right? Now virtual short concept is valid or not valid, it depends upon the negative feedback. Last question, tell me. For example, this diagram. Let 0.5 volt as the input is connected here. This is the V naught. This is 1 kilo ohm is connected here, 10 kilo ohm is connected here, 10 kilo ohm is connected here, 2 kilo ohm is connected here. Now what will be the output? For example, that will be the question. What will be the output for this particular question? It may be inverting or it may be non-inverting, it doesn't matter. Right, how to solve this type of questions? Both the feedbacks are present here. Both the feedbacks are present here, 10 kilo ohm, 2 kilo ohm, 10 kilo ohm, 1 kilo ohm. Then first of all make this Vn is equal to 0 and then find the value of Vn and then find the value of Vp in terms of what V naught. For example, let the Vin is equal to 0.5 volt tends towards 0, make it short circuit. Then find the Vn, it will become 1 divided by 1 plus 10 into V naught, that is nothing but 1 by 11 V naught. Vp is nothing but 2 divided by 2 plus 10 into V naught. Simple voltage division rule, because what is the current enter into the op-amp? 0. That will become 2 V naught by 12. 2 V naught by 12 and that is nothing but V naught by 6. Now it is visible that Vn is less than what? Vp. Vn is less than Vp or Vp is greater than Vn. Which feedback is dominant? Everyone tell me. In the particular diagram, which feedback is dominant? To make the V, all the V0, right? Positive feedback is dominant. If remember, if the positive feedback is dominant, why we are not using the positive feedback in during amplification or control system? Because op-amp will enter into what? Op-amp enter into saturation. Directly it will enter into the saturation. So what will be the output? Output will be maybe plus V set or minus V set. Plus V set or minus V set. That is the output. We can't see. In the coming session I will explain what will be the exactly output, plus V set or minus V set. So operational amplifier will enter into saturation. That is the saturation. And that's why the output may be plus V set or minus V set. We have to check. I think that is also clear how to check the negative feedback and positive feedback, which feedback is dominant and so on. If there is a current source, always remember, already we have some questions in previous year question paper. Current source is available, make it open circuit. Current source is available and then make it what? Open circuit. Simply. Or if the voltage source at the input side, make it short circuit, get the Vp, get the VL. If the Vn is greater than Vp, negative feedback. Vn is less than Vp, positive feedback. Positive feedback, if dominant, op-amp enter into saturation. Yes, we can use as a waveform generator or what symmetry trigger, right? Or what bistable multivibrator, as a flip flop, binary and so on. तो ये है concept. तो ऐसा नहीं है that this circuit is not useful as amplifier or what control system, but it is useful for what as symmetry trigger or what bistable multivibrator. Hope so it is clear. So that is all about the non-inverting op-amp and inverting op-amp, and with some new concept. And then if you want this type of sessions, then please subscribe our channel. Try to solve this question. This is very easy one. The given circuit has a unity gain bandwidth of 12 kilohertz. What will be the bandwidth of the circuit? That is the assignment for you. Try to solve this question and give me the answer in comments box, and I will mention your name in next class. I will take a screenshot of that comments and then I will mention your name. So that is a very simple question from the voltage follower. If the gain bandwidth product is given, what will be the gain, and then what will be the bandwidth of the system. Second, that is the question. This is the current is given I1, that is the I0. In the circuit you have to find the I0 upon I1. Assignment number 2. Simple answer in comments box. Okay, this is the assignment number 2. Try to solve in coming classes. We will solve all the assignments. Already I have given 2 questions from inverting operational amplifier, 2 questions on non-inverting operational amplifier, and if you are solving the previous year question paper, and if you are finding any difficulty related to what inverting, non-inverting or what voltage follower, then you can ask. Yes, Sapna, in next class I will discuss that is the question on inverting, non-inverting and what voltage follower. Okay, if suppose you are solving some question or you are finding some difficulty related to that, inverting, non-inverting, voltage follower, or related to basics of the operational amplifier, then take a screenshot of that, post in my Telegram channel. I will go through that particular question and I will explain the solution of that particular question on that our coming sessions. Okay then, thank you very much. You are on BYJU'S Exam Prep. Like the session, share the link of this session and subscribe our channel. Thank you and good day.